Hi, today you are going to take a look at this vintage aircraft unit. This thing is called the CRT and camera unit. I have also this document here. You see the reference of the aircraft in which this thing was installed, the deficiencies nil. And here it seems that there is a fault, fails X deflection test. On the top here there is a compartment. It seems that an 8mm film or something like that should be installed here. If you recognize the standard of this film, please leave a comment. There is the serial number 134. There is one connector here, a J3. There is a time totalizer. It indicates 754 hours. And on that side, there is one coaxial connector. There is a circular connector. We have here two identical amplifiers for X and Y deflections. And here we have effectively a CRT. Okay, so we can see that we have a prism here. It permits actually to record a video signal to an argentic film. Probably this thing is used in association with a low light camera or something like that. And this permits to record the videos on an 8mm film. Quite interesting. So here we have the high voltage power supply for the CRT. We can see here the post acceleration. So we have here a voltage of approximately 8 kilovolts, exactly between 7.6 and 8.4 kilovolts. So here this is the input voltage, 28 volts. And here we have the first acceleration, 1.2 kilovolt. We have here several power resistors. We have here the optics. And you can see here a prism. So this seems to be a micro switch. So this is effectively a micro switch. I didn't see, but it is activated by this small plastic stuff. So this permits to know if a cartridge here is inserted or not. And here there is a stepper motor. So you can see also a gear train. The stepper motor is connected here, and we can see 4 freewheeling diodes here. The micro switch is connected here to 2 pins of this sub-D 15 connector, and there is also a trimmer which is connected to this connector. Okay, so the coaxial input here is connected to this connector. So this is the video input signal. This board seems to be the video amplifier. Okay, so the video signal is connected to this resistor here of 75 ohms. And the output somewhere here should be connected to the cathode of the CRT. We have on that system the X and Y amplifiers and the video amplifier. What we can do is to remove everything, and it should be possible to display something. Oh, that's interesting. So this is a phototransistor, a photodiode. And here it seems that we have small LEDs. I don't understand exactly. It's maybe for self-test. So this photodiode permits probably to have an automatic control of the contrast and luminosity. I can see the prism is semi-reflective. I can see that this is effectively a small LED. A few moments later. We have here the complete electronic assembly. We have here a prism. And this is the optics. So here we have the CRT, approximately 3 centimeters diameter. We should have an electromagnetic deflection. And we have here an electrochemical capacitor. And here the high voltage power supply. I did a quick reverse engineering of the CRT connection here. We can see the result here. There are two wires which are used for the heater. There is a green wire which is connected to this board. We have here this small circuit. So we can see the polarity of this capacitor. So this voltage is negative relative to ground. Therefore, this terminal corresponds to the VNELT of the CRT. This potentiometer permits to adjust the luminosity. We need to apply an external negative voltage to this point, something which is below minus 20 volts, which is the cutoff voltage of this CRT. It is written on the sticker here. There is another wire, the violet one, which is connected to the output of this high-speed op-amp. This is the video amplifier. The video input is here. There is a load of 75 ohms. There is a gain which can be adjusted from 3 to 10 by this potentiometer. This permits to adjust the contrast. Therefore, we have the cathode terminal here. And there is another terminal corresponding to this blue wire, which is connected to one terminal through this shielded cable. So obviously we should have here the focus. The focus should be adjusted externally. And we have these two deflection amplifiers. The schematic is here. You can see that the feedback of this amplifier is here. You can see that there is a current sense resistor. The output of this amplifier is here. It is connected to the deflection coil, and the current returns to the ground. And there is here a feedback. Therefore, the current flowing through the deflection coil is proportional to the input voltage here. You can see that they have used two transistors here instead of two diodes for the compensation of the base emitter voltage junction. There is a power stage. These two transistors are not located on the board. The power stage is here. The transistors used for the vertical and horizontal deflections are not the same. There are two medium power transistors here, I assume for the vertical deflection, and for the horizontal deflections, the transistors are not the same. There is one with a medium power, and the second one is a TO3 transistor here. For the moment, I have disconnected the amplifiers, and we can see that we have a spot. The color is blue. So it is difficult to see with the camera, but the diameter of the spot is very small. I can increase the luminosity. Okay, I don't want to burn the screen, so I will not insist. Okay, so next step will be to reconnect the amplifier's board. I made this simple high voltage generator for the focus power supply. The voltage can be adjusted from 0 to 1 kilovolt approximately. Currently the voltage is approximately 200 volts. We can see that we have a vertical deviation.